Okay, so let's look at section A. So MCQ questions. Section A, especially this type of MCQ question, you shouldn't be like having this type of questions wrong. Okay, so when they say in which of the following numbers does the digit 6 stands for 600, it's quite easy. Okay. Yes, Xavier, you can do your corrections on the OAS. Do we just do corrections? No, not just on the OAS, you can actually do it on the paper as well. Okay, you can write down the notes and the things like that. Okay. Wait, Caleb is coming. Okay, thank you.
But we only need to do the corrections on the OAS, right?
Yes, but the thing is that you also can write down notes that on the questions that why you got wrong, right? You know, like if you only got question 1 is wrong, then yes, you can do it on OAS. Okay, so yeah, in which of the following numbers does the digit 6 stands for 600? So guys, let's look. 600, there's actually 3 digits, right? So you can actually focus on the hundreds place. So there you go. Question is number 3. Okay, so here so this type of question shouldn't get wrong. Try to minimize your carelessness. Question 2, what is the remainder when 8,345 divided by 8? Okay, so your long division, okay, your multiplication has to be strong. So 8,345, we do 1 by 1. So 1, you get 8 here, so you get 0. Bring down the 3, okay? So you bring down the 3 here is 0 because 3 is smaller than 8. So minus 0, you get 3. Bring down a 4, you got 34. 8 times table. So students who wish to make sure that they don't make any careless mistakes, they can actually write down the 8 times table at the side. Okay, so you can write down your 8 times table, 8, 16, 24, 32, then 40, then 48. It's a good habit to write that at the side. Okay, so you have 32 here, which is times 4. Then you get 2, and then you bring down the 5, which is 25. So the nearest to 25 is 24 here, which is 3. So the remainder here will be 1. Okay, so please take note that 1043 is a quotient and 1 here is the remainder. Okay, so number 1. Moving on to question 3. Okay, so question 3 here, 246 times 8. Okay, so we do it 1 by 1, starting from the ones place. So 6 times 8 is 48. You put a 4 here. 4 times 8 is 32 plus 4 will give you a 36, right? Okay, so here you go, bring down a 3. 2 times 8 is 16. 16 plus 3 is 19. Okay, so you will have 1968, which is 4. Okay, so these questions actually got many students wrong, so be careful. Okay, you can always double check. Okay, question 4, John bought 16 red and 18 blue pens, so he packed all of them into some bags. So each bag, okay, has the same number of red pens and the same number of blue pens. So which of the following shows a possible combinations of the number of red and blue pens? So I believe that these are questions students get confused because they see this word here, this statement here. Each bag has the same number of red pens and same number of blue pens. So they will be asking, is it that red and blue pens has the same number? Actually, no. They're just telling you that, okay, you pack them into bags, right? So every bag will have the same number of red pens inside, and every bag will have the same number of blue pens. They do not have equal red pens and equal blue pens. Okay, so what we do here is that red you have 12. Okay, so I'm finding the factors of 12. Okay, so list down. Remember, you do factors and multiples in P4 at the beginning of your year. So you have 2 times 6, 3 times 4. And then 18, you have 1 times 18, 2 times 9, 3 times 6. Okay, so in this case, here you go. Okay, same number, which is a possible combination. So you get 6. So 6 bags of 2 pens each. Okay, and 6 bags of 3 pens each. Okay, so that means you see 12 and 18, they must divide that they give you the same number of bags, right? So in each bag, you will have 2 red pens, and in each bag, you will also have 3 blue pens. Okay, so here you go. This will be number 2. Okay. Question 5. In which of the following are the numbers arranged from the greatest to the smallest to the greatest? So you need to start from small to big, okay? So what you do is that you look at individual numbers. Since all the options given starts with 7, you should pay attention to the 100th place, okay? So you look at the 100th place and see which one is the smallest, okay? So number 2, you see? Yeah, there's more students coming in already. Okay, so it will be number 2 here. That is from the smallest to the greatest. Okay, so students, you need to be careful. Every option run through it, okay, and see which one is the smallest to greatest. So in this case, you see, this is wrong because 7,842, okay, it's actually bigger than 7,824. Hold on. Okay. Thank you. So question 6, the time is now 4 p.m. What time would it be if the minute hands move 3/4 turns clockwise? Okay, so yeah, here you go. So 3/4 turn clockwise. First thing first, you know what's your clockwise direction? Okay, so clockwise directions is starting from 12, moving down here. Okay, so now it's 4 p.m. So clockwise direction is this position here, okay, and then you turn. So from 12 to 3 is 1/4, 3 to 6 is another 1/4, and then 6 to 9 is another 1/4. So that's why they request for 3/4 turns clockwise. So what time would that be? It will be at 4:45, okay? Question 7, what is a common factor of 16 and 36? Okay, so factor means what? Definitely the number must be lesser than 16 and 36, okay? So which means that when 16 and 36 divide by this number, it doesn't give you any remainder. So we are finding, so we use this, okay, T method. So 16 would be 1 and 16, 2 and 8, 4 and 4. 36 will be 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. So what is the common factor for 16 and 36? So both of them has 4. So 4 is a common factors of 16 and 36. Question 8. John baked 900 cookies. Okay, he in this case is referring to who? John. Okay, always practice, you know, every time when you read it, you understand. Okay, you need to not saying you need to underline. It's a good habit that you tell yourself, okay, this he is actually referring to John. Okay, so he baked 3 times as many cookies as Yenny. So how many cookies must John give to Yenny for both of them to have the same number of cookies? Okay, so John is 3 times as much as Yenny, right? So which means that John has 2 units more than Yenny. So in order for them to have the same, how many units here must John give to Yenny so they are the same? So give 1. Okay, so that means John has to give 1 to Yenny, then they will have the same. So what is this 1 box? What is the value of this 1 box? We know that John has a total of 900. Okay, so if he has a total of 900, so what will be 1 part here? So will be 900 divided by 3. Okay, because 3 units is 900. So 1 unit will be 900 divided by 3, which is 300 here. So the answer will be 2. Okay. So yeah, let's go on to the next question 9. So question 9, how many thirds are there in 5 wholes? Okay, so how many thirds are there? Here you go. So 1 whole, you can cut 3 equal parts. If you have 5 wholes, you will have 5 times 3, which is 15. Okay, so that's what we have. This is a recorded student, so that's why I have to mute you guys. So here you go, 15 thirds. Question 10. Yenny bought 1/4 kg of apples and John bought 1/5 kg of apples. So how many apples did they buy altogether? So students, please take note for fraction. Okay, units is given here. So you see, this is units. So you need to make sure that the fractions both are in units so that you can actually add them together. So how many apples did they buy altogether? So it will be 1/4 plus 1/5. Okay, so when we add fraction, we need to make sure that their denominator is the same. Okay, so 4 and 5, what would be the lowest common multiple? So in this case is 20. So basically you can actually times each other to find the lowest common multiple. Okay, so you have 5/20 and 4/20. So you get 9/20 kg. Okay, I forgot what was the question. Wait now. Xavier, hold on. Question 9 is here. So they are asking you how many thirds are there in 5 wholes. So a whole can cut into 3 equal parts. So 5 wholes will have 15 thirds, 15. Okay. So this one was the common, lowest, you need to make sure that the denominator is the same, then you can add them up. So your answer will be 9/20 kg, so 3. Okay. Question 11. John bought 6 kg of apples. He gave the cashier $200 and received $44 change. So how much does 1 kg of apples cost? So first thing first, did John use up all his $200? No, because he actually received a change of 44. So you need to find out how much that he spent on these 6 kgs of apples. So total spent will be 200 minus 44, which is 156. And that is for 6 kg worth of apples. Okay. So to find 1 kg, which is 1 unit, you see 6 to becomes 1, you divide by 6. So 156 divided by 6 to find 1 kg. So it will give you $26, which is number 3 here. Question 12. This is something that most of you make mistakes on. Okay. When a number is divided by...
I'm not done with question 11.
Okay. So sorry. Okay. Question 12. When a number is divided by 8. Okay. So what we have here is this number. When you divide it by 8, it gives you a quotient of 2938 and a remainder 4. Okay. So you need to work backwards. You're finding this number. So isn't it this number has to be big? Okay. So how do we work backwards to find this number? So first thing first, we use 2928 times 8. Okay. So 2,928 times 8 will give you 23,424. So once again, you have to be very careful when you're doing this multiplication. Okay, have to be strong with your multiplications all the way until 12. Okay, so 23424 will be 2928 times 8 here. Don't forget that you have a remainder of 4. Okay, 23424 is because you can entirely divide by 8. But if there's a remainder of 4, meaning that 23424 has to plus 4. So will be 23,428. So that would be option 4 here. 13, I am a 4-digit number. The digit in the ones place stands for 6. So how do we do these type of questions? First thing first, if you know that you will have a 4-digit number, put boxes here to represent 4-digit number. You can always put your place value here, ones, tens, hundreds, thousands. Okay, so it's actually a good way. So you can read one by one. So the digit in the ones place stands for 6. So you can put this first digit here. The digit in the tens place is 3 times the digit in the hundredth place. So, okay, I'm not sure how much is my 100th place. I don't know what is my tens place, so I read on. The digit, okay, 4 is in the thousands place. Here you go. So what number am I? So this is actually very good. It's because it's given in MCQ questions, okay? Hold on now. Okay, so you hear, that's what I mentioned just now. 6 and 4. So you can have a look here. This will definitely be out because you know that your thousands place is 4. Okay, and you end with a 6. So you see, this is out. Okay, then now let's look at the next one. So you're left with 6 and 2 and 2 and 6 here. So you're left with option 1 and 2. So what we need to take note is the tens place is 3 times the digit in the hundreds place. Okay, so these times 3 will give you the tens place here. Okay, so here you go. So this is 2 times 3 will be 6. Okay, so the answer will be question 2. Question 14. So 8 cones were placed at an equal distance apart in a straight line. So you read this. The distance between the first and the third cone is 24 meters. So find the total distance between the first and the last cone. So this question is actually an interval question. So number of intervals, meaning that, okay, from the first to the third cone, okay, how many intervals are there? So what you could do is that you can actually draw out your cones if you want, okay. So this is the first to the third. So how many intervals are there? There's actually 2. So you just use 3 minus 1, which is 2. So there's 2 intervals. And these 2 intervals, right, is actually 24 meters. Okay. So 2 intervals is 24 meters. 1 intervals will be 24 divided by 2, which is 12. So question wants you to find, okay, the total distance between the first and the last cone. Okay, so there's total 8 cones here. So 8 cones got how many intervals? Total 7. Okay, so 7 intervals will be 12 times 7, which is 84 meters. So that is option 3 here. Okay. (15) There were 96 sweets in a box. So both John and his brother ate 1/4 of the sweets. So both of them ate a total of 1/4. So John ate 3 times as many sweets as his brother. How many sweets did John eat? Okay, so what is the amount that they both John and the brother ate? Will be 96 divided by 4. Okay, why? Because this is the total number of sweets you have in the box, which is 96. 1/4. So that means it has been cut into 4 equal parts, right? So you need to find out what is this. So you use 96 divided by 4, which is 24. Okay, so that means John and the brother ate a total of 24 sweets. John, he ate 3 times as many sweets as the brother. So you see, that's why I draw 3 here and the brother 1 here. And if you know that, okay, these units here add up to a total of 24. Okay, so there's 4 equal parts. So 4 units equals to 24. So how many sweets did John eat? Okay, so every time you need to find 1 unit. So to find 1 unit, right, you use 24 divided by 4, which is 6. You divide by 4 because they are all 4 equal parts here. They are all equal parts here. So how many sweets did John eat? John here, which is 3. So 3 units will be 6 times 3, which is 18 sweets. So that's the total amount of John, the sweets that John eat. Okay. So students can actually see how many careless mistakes that you make. Okay. So moving on to section B. Okay. Section B. So section B, it's also whole numbers here. Okay. So you look carefully, there's a 63,000 and 52, okay? It's made out of what? 60,000 plus 3,000 plus what? Plus 2. So you're already given 60,000 and you're given 3,000 and you're given 2. So you are missing a 50. You see here? So 5 here is in the 10th place. So it's 50. Okay? Yep. Round 338,694 to the nearest hundreds. So where is the hundreds place? Hundreds place is here. Okay? So nearest 100. So this is the hundreds place. So look at the partner next to 6. Okay? So you look at it. So 9 is actually bigger than 5. So you will round up. Okay? So it will give you 38,700. Okay? So that's for question 17. Question 18. What is the missing digit in the box? 1,572 times 6 give you a certain number. So I need to find this missing number here. So how do I do it? Okay, so you can always start times them. Like for example, 2 times 6 will give you a 12. That's why you put a 1 here. 7 times 6 give you 42 plus 1 is 43. You put a 4 here. 5 times 6 give you 30 plus 4 will be 34. So the number will be 4 here and 3 here. So 1 times 6 is 6 plus 3 is 9. So what is the missing digit? So the missing digit here is 4. Okay. Next question 19. 2,335. Okay. So most of the time when I see these type of questions, what I like to do is that, I put a bracket so that I know what are their values in numbers. Hold on. Let me answer Xavier's question. So Xavier, because the thing is recorded, so what you could do is that after everything is done, you stay back for a while and you look through the question 14 and 15 again. Okay, so this is what I like to do. Like 2,000, I'll write down the number. Okay, and then 3,500, take note, hundreds. Hundreds got how many zero? 2 zeros. So that's why 3,500 will be 3,500. 11 tens. Tens got how many zero? 1 0, right? So I put a 1. 20 ones. So 1 doesn't have a 0, so it will be 20 here. So 2,3,500 will be 2,000 plus the 3,500. Okay, so if you didn't see the 100, you just put 35. Okay, you get wrong. So 2,000 plus the 3,500 will give you 5,500. You minus away 11 tens. Okay, so 11 tens is 110 and 20 ones will give you 130. 5,500 minus 130 will give you 5,370. So a student has to be very careful when you're doing these type of questions. 20, what is the product? Product means times, okay? So what is the product of 314 and 27? So take note that this is a 3-digit times a 2-digit, okay? It still follows with 1 digit. You always start with the ones first, okay? So we start from 4 with 7 first, okay? So 4 times 7 will give you a 28. So you put an 8 and you put a 2 here. 1 times 7 will give you a 7 plus 2 will be 9. 3 times 7 will be 21. Okay, so this one you already achieved for the blue part, blue section here. So you're moving on to the red section. Don't forget you need to put a 0 before you start because the red section here, the 2 is in the 10th place. So you have to put a 0 here. So 4 times 2 will give you 8. Okay, so 1 times 2 will give you 2. So don't confuse, there's a 2 here. Most of the time, what I usually advise students is that after you complete the top level, you can actually cancel this off so that you can proceed on to the second level. Okay, so you have 2, and then 3 times 2 will be 6. So you add them up, you get 8, 17, you put a 1 here. So you get a 4, 6 plus 2 is 8. So it gave you 8,478. Okay. 21, you see the hundreds and tens here, so you have to be careful with these hidden words here. 300 more than 9,020. So 300 will be 300. More means you plus 9,020. That will give you 9,320. Okay, so if you straight away never read this question, you just put the 9,320, you will get wrong because it mentions it's equals to how many tens. Okay, so 9,320 equals to how many tens, right? So it gives you 932 tens. Remember just now when I say 100, you put 2 zeros, right? So now I say that the tens itself represent 1 zero already. So how many tens will be 9,320? So you only need to put 932, okay? Because 932 tens will give you 9,320, okay? 22, and Betty, Clara shared 7,435 marbles equally among themselves, okay? So Betty bought another 39 marbles for herself. How many marbles could Betty have in the end? Okay, so they shared it among themselves equally, meaning that we would use 7,437 divided by the number of girls here. So that's total 3, so you divide by 3. So long division has to be careful. So you can always write down 3 times table at the side, okay? So you can only have 2, which is 6. So you're left with 1. Bring down the 4. So 3 times table doesn't have 14. The one nearest to 14 will be 12. 3 times 4 will give you 12. See, 3 times 4, 12. So you were left with 2 and we bring down the 3. So 3 times table doesn't have 23. The nearest to 23 will be 21, which is 3 times 7. Give you 21. So you're left with 2. Bring down the 7. So 3 times table, there is 27. So 3 times 9 will give you 27. So each girls will get 2,479 marbles. So we are looking at Betty here because she bought another 39 marbles for herself. So how many marbles would Betty have in the end? So 2,479 is at first, and she bought another 39. So at the end, right, you just have to add the extra 39 that Betty bought for herself. You will have 2,518 marbles. Okay, so that will be the marbles that Betty have in the end. Question 23, container X and container Y has 130 grams and 246 grams of sugar respectively. Respectively means that X will be 120, Y will be 246, okay? How much sugar must be transferred from Y to X such that both containers have the same amount of sugar? Okay, so you want them to be equal, they want to be the same. So what should we do first? So I show you the model here. Y is extra. Y is actually more than X, right? So how much more? So we use 246 minus 130, which is 116. So this whole thing is 116. To make sure that you give them equally, what we do is that this extra here, we just have to divide by 2. Okay, so when you split it into 2, this portion here will go up. So isn't it at the end of the day, both containers has the same amount? Okay, so therefore 116 divided by 2 will be 58. So yeah, our container Y has to give 58 to X so that they have the same amount of sugar. Okay, so the answer will be 58 grams. Remember to write your units. No units will be marks deducted. 24, Two of the common factors of 16 and 64 are 1 and 2. So what are the other three common factors of 16 and 64? So factors again, you see, when you see factors, what do? We use the T methods, okay? List down what are the numbers that give you 16. That means when this number times this number will give you a 16 here. So we always start from the ascending order. We start from 1 first. So you have 1 and 16. 16 is an even number, so you can be having 2 times table. So 2 times 8 will give you 16. Then you ask yourself, is there a 3 times table? 3 times table got 16? No. 4 times table, is that 16? Yes. 4 times 4. Okay, so students, if the number repeat, right, that means this is the end already. Okay, so you no need to guess whether do you still have any more. So this is actually a good gauge to see that, okay, that means this is the max that you have for 16. Okay, moving on to 64. Same thing, 1 times 64. 64 is an even number, so you can have 2. So 2 times 32. So 64, give you a trick. When these two numbers add together, okay, it's in the answer is in a multiple of 3. It can be divided by 3. So like for example, 6 plus 4 is 10, right? So 3 times table doesn't have 10. Therefore, 64 cannot be divided by 3. Okay. 4 times table, yes. We have 4 times 16. Okay, and 5 times table also very easy. Look at the last digit, which is the ones place. So if it's n with 0 and 5, definitely can be divided by 5. So in this case, 5 times table doesn't have 64. Okay, moving on to 6, there's no. You can have only 8. Okay, so 8 times 8, that's when you know you need to stop because it's repeated number. Okay, so these are the factors for 16 and 64. So we are finding the common factors that both of them have. Okay, so it's 1, 2, 4, 8, and 16. So 1 and 2 is already given. So what are the other three common factors? So 1 and 2 is given already, right? The other three will be 4, 8, and 16. Question 25. This is a lot of, this is actually quite a very bad because there's very high percentage of students get it wrong. Okay, so students, please take note. Protractor, there's 2 sides. If you look carefully, okay, so there's actually a 0 here at the outer side. So when you start from 0, you should look at the outer part here. And if you look at your right hand side, the 0 is actually at the inner part. Okay, so what actually most of the student mistake is that they actually look at it the wrong way. Okay, so you see, you start from 0, you should look at the inner part here. Got it? Okay, so you need to find out the angle that is equal to 75 degrees. Okay, so first thing first, you should see where you start with the position. Okay, so I want to show you from A, B, D. You look here. So you started off at A, so you should be looking at 0 at the outer area. Look up. Okay, so you see, you look up here. So this is actually 55. So A, B, D is out because you are finding 75 degrees. Got it? Now, let's look at A again. A, B, E. Do you see? A, B, E. So when you see A, B, E here, what do? We start at A again. So we'll be looking at the outside range. Okay? So look at the outside. A, B, E. Wow. Let's look here. Do you see? So we'll be looking at the 100 and not the 80. Yeah? So this is 105. Okay, so students don't make careless mistakes. This is not 75. You are looking at the outer side because you start from A here. So when you start from A, you should find your 0. Everything when we measure, we start from 0, right? Okay, so therefore, A, B, E is not 75, but 105. Okay, now let's look at C here because we have 2 different points, right? You see 0 and then we have C. Okay, let's start from C. So if I start from C here, I'll use another color to show you. So if I start from C here, I will look at my 0 here. Okay, so I ignore the outer one. I'll look at the inner one. So C, B, F. Okay, C, B, F, it's here. Do you see? So it's 60 and 70 in between. So this is 65. So CBE is out as well. Okay, then moving on to the next one. How about CBE? Do you see? C again, we start from C, we look at 0 here also. CBE. So CBE, which all the way until here. So you see, look at this point carefully. Between 70 and 80, it is 75. So ta-da, that's why you find 75. So angle CBE will give you 75. Student, if there's no this symbol here, the angle sign, you won't get the marks because they ask you to name the angle. Okay, you don't tell me you name angle C. Where is angle C? Angle C, there's no angle C. C is just a point. Okay, so when you want to find an angle, you need to name CBE because C connect to B, connect to E, form this angle here. Okay, so you have to be very careful what you're answering. Oh, I think I read somewhere some of the students, also some of you, they ask you to name, so you know, you don't give me your name as acute angle. Okay, I know this looks like a acute angle, but do you see that the diagram is given with all the alphabet? Okay, so they are not asking you to name acute angle, obtuse angle, or a straight line. So they want to know which is the angle that gives you 75. Okay, so then be careful with that. Question 26. What is the sum of the third multiples of 6 and the fifth multiples of 7? So third multiple of 6 means that quite simple, will be 6 times 3, okay? So which give you 18. Take note that this is sum, and the fifth multiples of 7 will be 5 times 7, which is 35. So sum means plus, so you use 35 plus 18 will give you 53. So that will be question 26 answer, okay? Question 27, here you go. A line XY has been drawn for you. Using a protractor, draw an angle such that XYZ equals to 145. Mark and label the angles drawn. So this question, I still see students making mistakes, okay? So what happened was that, okay, I noticed is that, you know, sometimes students just put like that, then they put the Y here and it starts to draw the Z, which is actually wrong because X and Y is given here. So you need to follow what is given here, then you start drawing, okay? You don't create your own alphabet or your own line, okay? So what happened was that they asked you to draw X, Y, Z. X, Y, Z. So Z can be anywhere here. So meaning that, okay, Y will be the connecting line for X and Z. So where do you put your protractor? Should I put at X or should I put at Y? So you should put at the center alphabet here. There's 3 alphabet. You should put at the center position, which is the second position here. Okay. So in this case, my protractor will be at Y. So I usually have a good habit is that, right, I will actually draw a small line here so that I know, right, my protractor, this line will place nicely here. Okay, so you can start reading from there. So do you see? It was nicely drawn here. Okay, you must put at this point. So you see, right, this is actually a good gauge for you. When you draw it, you know that where you should place the protractor properly. Because this question is actually easy. Teachers are very, very strict when marking this type of question. So if you have a difference of 1 degree, right, the teacher might not give you the answer. Okay, they only can accept a bit difference. So you need to be very careful. Okay, so you start from 0 and then you see, you start from here, right? X. So you should be looking at the outer value here. So you are finding 145. So you start from 0, go all the way up. Okay. So 0, 145 will be here. Then I start to put a point here. Okay. Then you draw the line up. Okay. So that's how you get your answer 145. And by looking at 145, you definitely know that it's actually a obtuse angle. Okay, so it definitely has to be very wide open, like it opens up. Okay, so take note, you need to label Z, okay, and record 145 degree here. Okay, so take note of this. Question 28. Okay, so write 19 over 4 as a mixed number. So this is an improper fraction. So mixed number, we need to see, okay? So 19 over 4, you will have 4, 3 over 4. Okay, there's actually a few ways to doing it, okay? So 19 over 4, to give you a whole number, right? You need to see how many 4 over 4 can you take out, correct? That's one way. So you want to see how many 4 over 4 you can take out. So you can actually take out 1, 2, 3, 4. So that's why you have a 4 whole. The next method, right, will be 19, you divide it by 4. Okay, so the best you can have is 16. 4 times 4. Then you're left with 3. So you see, you have a 4 whole, remainder 3 over 4. So that's how you get 4 whole 3 over 4. Okay, arrange the following fractions in descending order. Take note of what is descending. Descending, it starts with D, right? Going down, meaning from big to small. Okay, so change to same denominator. 6, 3, and 3. 3 can become 6, so you just have to times 2. So you have 1 whole 2 over 6, okay, which is 8 over 6, times 2, which is 4 over 6. So now you compare, okay, the greatest will be 9 over 6. Do you see here? Okay, so you have 9 over 6 followed by 8 over 6. So students don't leave it as 8 over 6 because this is just a working, right? So you should leave it at the original fraction, which is 1 over 3, followed by 2/3. Okay, so that would be your answer for question 29. Okay. Question 30, a pair of shoes and 4 tennis rackets cost 3,780. Tennis racket costs twice as much as a pair of shoes. Find the cost of a tennis racket. Okay, this is a typical type of questions for stacking model. So I have a pair of shoes, but I have 4 tennis rackets. Okay, tennis racket is more expensive. It costs twice, double of the shoe. So when I draw 1 unit for my shoes, tennis racket will have 2 units throughout. And that gave you a total of 3,780. Okay, so how many units are there altogether? There is 9. So 9 units is 3,780. 1 unit will be 3,780 divided by 9, which is 420. Find the cost of a tennis racket. A tennis racket is 2 units. So 420 times 2, which give you $840. So that is for question 30. Okay. 31. There are 340 cakes in a box. 3/5 of them are strawberry cakes, and the rest are mango cakes. So how many strawberry cakes are there in the box? So I draw out my model because fraction is given. So 3/5, I'll draw 5 equal parts. So the total amount of cakes in the box is 340. 3/5 are strawberries, and the rest are mangoes. Okay, so 5 units give you 340. So what is 1 unit? Okay, so 1 unit will be 340 divided by 5, which is 68. Question asks how many strawberry cakes? So there's total 3 units, right? So 3 units worth of strawberry cakes will be 68 times 3, which is 204. Okay, so the answer will be 204 strawberry cakes. Most of you got it. Okay. 32. Donna has some stamps. She gave 5/8 of her stamps to her best friends. Okay, so I draw 8 parts because 8 is the total units that she has. 5 of that is to her friends, which is her best friends. And then this is the amount that was left. And this amount we are given a value, which is 51. We know that she has 51 stamps left. How many stamps did Donna give to her best friends? So 3 units is 51. 1 unit will be 51 divided by 3, which is 17. Okay, so you read the questions. Question wants to find out how much does Donna give to her best friend. So the best friend got 5 units. So 5 units will be 17 times 5, which is 85 stamps. Okay, so that will be the amount of stamps that Donna gave to her best friend. Okay, 33. A lot of students got it wrong. Let's see. Mother bought 2 kg of flour. She used 2 over 3 kg of it to bake some cookies. Okay, so then what happens? And 29 kg of it to bake cupcakes. Okay, so how much flour does mother have left? Students, take note. These are all in units, right? You see? Okay, so that means 2 kg. You used 2/3 to make cookies. So the total amount she used to make cookies and cupcakes will be 2/3 plus 2 over 9. Change them to the same denominator because it's from the same amount of flour. So you will have 6 over 9 plus 2, 9, which is 8 over 9 kg. Okay, so this is the total amount used. So questions just want you to find how much was left. Total is 2 kg at first. So amount left will be 2 minus 8 over 9. Okay, so 2 is actually a 2 whole. So how do we do it? Okay, we change them to a fraction. So you can take out 1 whole and change it to a fraction, which is 9 over 9. Okay, so 1 whole 9 over 9 minus 8 over 9 will give you 1 whole 1 over 9. Okay, so the amount of flour left will be 1 whole 1 over 9 kg. (34) A number is 13,000 when round off to the nearest thousand. So what is the greatest possible values of this number? So we draw out our number line. So 13,000 is the answer when it's rounding off the nearest thousand, correct? 1,000 before 13,000 will be 12,000. 1,000 after 13,000 will be 14,000. So what is the midpoint? Okay, so here is the center point whereby, okay, when you round it off, okay, 12,500, okay, any number is within this range to this range will be giving you 13,000 when rounding off the nearest thousands, okay? Same as here as well, okay? So you want to find the greatest possible value. So if you write down 13,500, your answer is wrong. Why? Because 13,500 will give you, when rounding off the nearest thousand, 14,000. So you should use 13,500 minus 1. So you'll get 13,499. Okay, so that will be the greatest number when rounding off to the nearest thousand. So you can do a check. Rounding off the nearest thousand, this is your thousands place. Look at the partner behind. As long as it's less than 5, you don't round off. So that's why it will be a 13,000. Okay, so the greatest value here will be 13,499. So this is a number pattern question. It's a pattern question. So look at the patterns below. So you have matrix, matrix, okay? So what letters is in the 32 position? First thing first, matrix, matrix, okay? So in one group, you have a total of 6 letters, okay? So you want to find 32 position, okay? How many groups are there? So we use 32 divided by 6. That means you have maximum 5 groups of full matrix, right? Okay, you have 5 groups. Now, what will be the remaining 2 letters? So you have 2 letters left over. So the 2 letters will be M and A, right? So, see, matrix, matrix, matrix. After that, you left with the last 2 number. So will be 1, 2. So the alphabet is A. Okay. 36. So Tom bought 15 cream puff. He ate 4 cream puff and gave 6 cream puff to his cousins. So the question asks for what fractions of the cream puff does Tom have left? Give your answers in the simplest form. So they want it to be in a form of fractions, okay? So left will be 15 minus 4 minus 6. So you have 5. So this is the value of number of cream puffs left. So how do we put them in a fraction? So a fraction has numerator and denominator, correct? So denominator will be the total number of cream puff. Numerator will be the values that you want to find. So in this case, we are finding left. So 5 will be on top. So will be over total number of cream puff, which is 15. Okay. So take note, you need to leave it in your simplest form. So both can be divided by 5. So you have 1/3. Okay. So question 36 answer is 1/3. So we are moving on to the problem sum question now. Okay, which is section C. Okay, section C, 37. The sum of 2 numbers is 5,056. The greatest number is 3 times of the smallest number. So what is the greatest number? Okay, so I have greater number and I have smaller number. Okay, they are not equal number. And the hint here, they tell you that the greater number is 3 times. So I will draw 3 boxes. So which means that my smaller number will only have 1. And the total of these two numbers is 5,056. Okay, so far? Now, first thing first, 5,056, right? Give you 4 equal parts here. So 4 units, okay, will be 5,056. 1 unit will be 5,056 divided by 4. Okay, so you get 1,264. Okay, so what is the greater number? So you want to find greater number? Let's look here. Greater number in this case is actually 3 units here. So 3 units will be 1,264 times 3. You will get 3,792. So that will be your greatest number. Okay. Moving on to 38. 38 got a lot of students got it wrong. Okay. So yeah. Let's see. So 38 here. Okay. Thank you. So here you go, 38. Sam saved 3,352 in the past 10 months. Okay. He saved 168 each month in the first 6 months. He saved the same amount each month for the last 4 months. So how much did he save each month in the last 4 months? I think students get confused, right? So you know there's a total of 10 months. Okay, so I have first month, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so you see, this is first, second, third, fourth, fifth, sixth, seventh, 8, 9, and 10. So they told you, okay, question says that he saved 168 each for the first 6 months. That means from here to here, every month is 168. Okay, so every month is 168. Now, the remaining month, he saved the same amount. But then they want you to find how much does each month he saved in the last 4 months. So these questions, right, you don't get yourself confused. So if you know that first 6 months, you save 168, and student, it's really very, very good that you actually write down what you're finding, okay? You don't just do the steps, because when you do the steps, right, you're not sure what you're finding, then you make yourself careless mistakes again. So what you do is that, you know, the total saved in the first 6 months will be 168 times 6, which is 1,008. Okay, so what will be the remaining amount for the last 4 months? You use your total here, minus away the total amount that you save for the 6 months, correct? Okay, so that means the next 4 months, which is the last 4 months, you save a total of 2,344. Question asks, how much did he save each month in the last 4 months? So 4 months, he can save 2,344. So each month, how much can he save? It will be 2,344 divided by 4. So which means that the last 4 months, he saved $586 every month. Okay, so take note, take note of these questions because a lot of you got it wrong. Yeah, the percentage of these questions getting wrong is actually very high. Okay. Question 39. John had 314 sweets at first. So after giving 19 sweets to Tom, Tom has twice the number of sweets as John. How many sweets did John have at first? Okay, so this is like your before, change, and after. So first thing first, John had 314 sweets at first. Tom, I'm not sure, okay, but there's a change. Okay, so what is the change? So after giving 19 sweets to Tom, so who gave 19 sweets to Tom is John. So that's why John here minus 19. And take note that Tom plus 19, okay? And that results after a change, right? Okay, so when there's a change, definitely there will be an after. So at the end, Tom has twice as much as John. How many sweets did Tom have at first? So look at here, okay? Look at this whole diagram here, okay? When you record, it's much clearer. So we can find what is John after, because you are given a before and you're given a change, isn't it? We can find after. So we can find how much does John have at the end, okay? So John at the end will be 314 minus 19, okay? Which is 295. So this one unit here is 295. Can you find Tom at the end where he is double of John? Yes. So Tom after will be 295 times 2, which is 590. Okay, so after, meaning that John received something. Okay, Tom received something, sorry. So Tom received 19 from John, and that's why Tom has 590 sweets at the end. So now we are finding how much does John have at first. So we are working backwards, okay? So we are finding before Tom received 19, okay? So which means that 590 minus 19 will give you 571, okay? So that is the amount that Tom have at first, okay? So Tom has 571 at first, okay? 40. So yeah, for 40, high percentage of people getting wrong. So let's look at 40. There was 5/7 kg of salt in bottle A. There was 1/2 kg more salt in bottle A than in B. More, okay? So what was the total amount of salt in both bottles? So B, how much salt is in B? You see, A is more than B, so B will be lesser. So we use 5/7 minus 1/2. So when you minus a fractions, always remember denominator has to be the same. So 7 and 2 will be 14, okay? So you will have 10/14 minus 7/14. That gave you 3/14. So which means that bottle B has 3/14 kg, okay? Question asks for what was the total amount of salt in both bottles, okay? So how do we find in total? So total will be bottle A plus bottle B. So A is 5/7, B is 3/14. Okay, same thing, change this to 14 here. So you have 10/14 plus 3/14, which give you 13/14 kg. So the total amount of salt in both bottles will be 13/14 kg. Okay, so always double check, is it in the simplest form? Is it in a mixed number? Okay. Next, question 41. Question 41, yes, also, yeah. Question 41 here is assumption questions, okay? Sorry. Okay. Just Xavier, if you want, you can do it after that because everybody is waiting for you, okay? So question 41, in a mathematics quiz, for every correct answers, 2 points are awarded, okay? So for every wrong answer, 1 point is deducted. So Yenny answered 40 questions and scored 53 points. How many questions did Yenny answer correctly? So yeah, some of you can do guess and check, okay? But in Matrix Math, we teach you how to do assumptions, which is like supposition. So first thing first, you know there's a math quiz going on, and Yenny actually answered 40 questions and she scored 53 points, right? So what do we do first is to find out what is the total score, okay? So in this case, suppose all questions are correct, okay? So there is 40 questions and each question is 2 points if they are correct, which means that this math quiz is a point 80, okay? So it will be 40 times 2, which is 80. So Yenny scored 53 points, okay? That means she makes mistakes, right? Okay, so how much mistakes did she actually make? So we'll use 80 minus 53, which is 27, okay? So most of the error, what happened was that student used 27 divided by 1 because every wrong question is 1 ma. So that's why I use 27 divided by 1. The answer is actually wrong, okay? And what is this good thing about supposition is that you can do a check after that, okay? So first thing first, I give you a situation. Imagine you got full marks for your math exam, okay? You get 100 marks. Oh my God, so good, right? So what happened was that when your teacher was going through, you realized that one of the question your teacher marked wrongly, okay? So she gave you extra 2 marks. So being honest, you go to your teacher and tell your teacher, say that, oh, teacher, I think you marked this wrongly. So what happens? What do the teacher has to do? She has to adjust your grades, right? So what happened was that she has to minus the 2 marks that you get where you don't deserve because it was wrong, ma. So you shouldn't be getting the 2 marks, right? At the same time, because it's wrong, you would also deduct 1 more marks because it's wrong. You're not supposed to get these 2 marks because your answer is wrong. So you have to minus 1 mark because the answer is wrong, right? So you actually lost a total of 3 marks here, okay? So that's why the total number of marks that you lost, right, is actually 3 here, okay? So 3 points was lost for every wrong questions, okay? So one exchange will be 3. How many 3 marks will give you a total of 27? So 27 divided by 3, which is 9, okay? So take note that there is 9 questions that you got wrong, okay? So how many questions did Yenny answer correctly? So answer correctly, total question is 40. So 40 minus 9 will be 31, sorry. So it's 31 here. So I love this supposition is because I can do a check. Okay, you actually can do a check. So if you know, right, okay, you have 31 questions that is correct. So you 31 times 2, so you should get your answer as 62, correct? But you got 9 wrong. So every time you minus 1 mark. So that means you will minus 9 marks, right? You will deduct 9 marks. So 62 minus 9 will give you 53. So that's why you see, you get back 53 and the total amount is, question answered is 40. So that's why this is actually a very good method, okay? So 31 question, Yenny answer correctly, okay? Question 42, John and Amber had a total of 540 stamps. Amber and Yenny has a total of 975 stamps. Yenny has 4 times as many stamps as John. How many stamps does Amber have? So much thing is going on. So what you need to do is you need to record them, okay? So when you record them, it's easier to see this way. John plus Amber will give you 540. Amber and Yenny will give you 975. Take note that I'm actually putting Amber in the same place here because they are referring to the same person, okay? So the only difference is actually John and Yenny. So why is there a difference in the total number of stamps? It's because Yenny has more stamps than John. That's why you see, when Yenny and Amber together, they have 975. So Yenny has 4 times as many stamps as John. So Yenny is 4 times as much as John. Do you see here? So another way you can draw your model is that, right? You know that Amber is fixed, okay? So Amber value is fixed. So John, Yenny is 4 times, so you can draw 4 here, and this is John. You see? So this to here is 540. Here to here is 975. So do you see there's a difference here? The difference is caused by who? Yenny, okay? So there's a difference of 3 units, okay? So here you go. So you find the difference, okay? So difference between Yenny and John will be 975 minus 540. That's the difference. So which is 435. So that is for the 3 units, okay? It's because Yenny has 4 times more than John. That's why there will be a difference in the value, okay? So 3 units is 435. So 1 unit will be 435 divided by 3, which is 145, okay? So we know that, okay, 1 unit is 145. So how many stamps does Amber have, okay? So you can actually use either one of this to find Amber. But the thing is that since I already know that John has 145, so you see, John here is 145, I can make use of John values to find Amber. Okay, so I just use 540 minus 145. Okay, so I'm making use of this. So you get 540 minus 145, you get 395. So you're able to find Amber. Of course, if you want to find Yanni, yes. But you know, why do we risk ourselves getting more careless mistakes? Because when you want to find Yanni, you need to use 145 times 4, then minus again, right? So therefore, we can use what we have for John, which is 145 here, to find Amber, because these two are the same. Okay, Amber in these two situations is the same Amber. So therefore, 15540 minus 145 will be 395. Okay, so that's the amount of stamps that Amber have. 43, John's father is 4 times as old as he is now. Okay, so I start putting 4 for John's father and John, and that is now. Okay, in 3 years' time. 3 years' time means what? 3 years later. Okay, their total age will be 66. So guys, not only the father plus 3, John himself also have to plus 3. Every one age, okay? So 3 years time, their total age is 66. So you don't just plus 1, 3, okay? Both of them age, okay? So father plus 3, John plus 3, okay? So that result that both of them has a total of 66. So how old was John 5 years ago? So what we need to do is that we need to find what is John's age now, okay? So this is after both of them add 3. They are 66, okay? So to find now, we use 66 minus 3 minus 3, okay? So 5 units, which is 1, 2, 3, 4, 5 here, will be 60. So 1 unit will be 12. 60 divided by 5 is 12. So here you go. So you know that now John is 12 years old, right? So you want to find how old was John 5 years ago. So 5 years ago, that means it's younger. So we use 12 minus 5, okay? So 5 years ago, John will be 7 years old. Okay, so take note of this question. Moving on to 44, where a lot of you got it wrong. Okay, there were 5 times as many men as women at a charity show at first. So during commercial, okay, 40 men left the show and 12 more women joined, okay? So in the end, there were an equal number of men and women, okay? So how many women were there at the charity show at first? How many adults were at the charity show in the end? So we do recording first. So at first, which is your before, men, it's actually 5, okay? And women will be 1, okay? So here you go. So what happened was that during the commercial, okay, 40 men left the show and 12 more women joined. So I'm not sure how much I should cut, but the thing is that the key word here is equal. So that means when I cut from men and when women added, right, they will have the same at the end of the day, okay? So this is 40 and then women, you added 12. And now they are the same. Do you see here? So it's okay when you read these type of questions, right? What you do is that you need to see that, okay, at the end of the day, you know, men left and women added, they will have the same. So mark them the same here. So you can see now they are equal, okay? So let's look here. Did you see that this model add out a total of 1, 2, 3, 4? Okay, so these 4 units, are we able to find the value? Yes. Okay, so this 4 unit is made up of 40 plus 12, which give you 52. 1 unit will be 52 divided by 4, which is 13. So that means every box is 13. So student, you need to make sure that you draw the models correctly. Don't draw the model too small. Okay, try to draw it at a bigger so that you can see how much you remove, how much you add, they will be the same. If it's too small, it's very hard for you to see, okay? So how many women were there at the charity show at first? So women, how many? 1 unit, right? So that means woman has 13 at first. Now, how many adults were at the charity show in the end? In the end here, okay? Adults are referring to what? Men and women, right? Okay, so you're finding at the end. So at the end, which is here, do you see this part here? Okay, so what should we do first? Okay, so 1 unit is 13. So women will be 13 plus 12, which is 25. Okay, so this one is very easy to find. But how about men? How do we find men? How do I know it's cut? How many units? How much is that? Okay, so what you do is that, okay, you use 25 times 2. Why? Because there were equal number of men and women. So women at the end, you got 25. Men will also be 25. Okay, so the number of adults at the end will be 25 times 2, 50. Okay, so this question, a lot of you got it wrong. Okay, so take note of this concept. Okay, so yeah, we have come to the end of the review. So those of you who already finished and done, no other questions, you can actually log off. Okay, so wait, let me stop the recording.